Recording, here we go, exercise 2G. So 2G, when you look at the questions, they are just application questions. They're just getting you to model. So unlike the previous exercise, you've got the equation, you find the x-intercept, find the y-intercept, draw the graph, find the gradient, etc. Now they don't give you the equation, you have to make the equation. That's why it's called linear models. So you're modeling it. So here we go, let's look at this problem here. It says the reservoir feeding an intravenous drip contains 500 mils of saline solution. What I'm picturing at the moment, someone in a hospital has a saline drip, little bag that contains, it looks like it's 500 mils. So this little bag contains 500 mils and it is attached to someone. Okay, so it's dripping in. What it says is the drip releases the solution to the patient at the rate of 2.5 mils per minute. So that tells me that after every minute, the 500 mils starts to drop by 2.5 mils. Okay, so it loses 2.5 mils every minute. So logically now they're asking you, A, can you construct a rule to do a prediction? So if I said after 30 minutes, how much is left in the bag? There has to be a way to calculate it, right? So when you calculate that, what's the model? How are you doing that? That's what part A is asking. So part A, construct a rule which relates the amount of solution left in the reservoir, which they called V. Okay, so I need to use V, find out the volume that's left over in this bag, okay, which is equals, because we're trying to find volume, and in terms of T. So T is in minutes, not hours. It's in minutes, not seconds. So in my case here, I know T now represents minutes, and good thing is the rate is also in minutes. If the rate is in a different time, then you need to then convert it. Okay, so if it's 2.5 mils per minute, then, and that was seconds, then you need to change that per minute to per seconds, okay, because that's per 60 seconds, right? So in our case, this is nice and easy now. So we know that we start off with 500 mils. This is our max. We started with 500 mils, but we know that over time, after 1 minute, it loses 2.5. After 2 minutes, in total, it loses 5. Because that's another 2.5. After 3 minutes, it loses 7.5, right? And you can sit there and write a table. You can write out, T, V, this is what you did back in year 7, 8, 9, and maybe even 10 as well, where you do a table of values and you would have done, starting at 0, you had 500 mils. After 1 minute, it's 500 take away 2.5, which is, what is that? I can't do it in my head. 497.5, is that right? And then 2, it should be then 495, and then 3, take another 2.5, it is 492.5, etc. Right? And what you did back in year 7, 8, 9, and 10 is you take these are your coordinates, have a graph, volume is your y values, or your dependent variable, and then t is your independent variable, so you would have t starting from 500 mils, and then you sketch. Right? You plot the points, 0, 500, 1, 49 something, but we're not doing that anymore. Right? We're not in year 7, 8, 9, 10 where we have to do X amount of points. You only need 2 points to sketch a straight line. So now that you've got the idea, we've got the general idea. How do we construct this equation? V equals what? You start with 500. How do I model that you lose 2.5 mils every minute? What would you do, Molly? Very good. So T 2.5 just means 2.5 times T. Because one of the things that we know is you're subtracting 2.5 every minute. So if you think about it, the first minute, you do minus 2.5. In the second minute, it's actually 500 minus 2.5 minus 2.5. This is two groups of it. That's why we do 2 times 2.5. So that's two groups, 2.5. And then 3 minutes, it's 3 times that. This is your model. That's what linear modeling is. Okay, so this here should represent the graph. Now, if I draw the graph on your CAS, let's go to your CAS now. I'm going to teach you a couple of things that will be very useful when we get to chapter 5 as well. So if you have a CAS, open it up. That's what we're going to do. From your home menu, I'm just going to start from the home. Don't use this. Don't use Scratchpad. In the past, I think it should be fine nowadays, but in the past, when you do that, you can't define and you can't do extra things that we normally add on top. We stick with this one. Okay, so use the calculator, not the scratch pad. So calculator, And I think it was to do when you do with spreadsheets and you start adding on other things that you do, it might not communicate. So stick with the calculator section. Open up a calculator page, you say 1.1 on the top there. So one of the first skills I'm going to teach you that I want you to be using every time we do an extended response question, application questions, or your SAC2. Those are the ones that allow you to use the calculator. This is what I want you to do when you get an equation. All right? You're going to go to menu, actions. Okay, you don't actually have to use the arrows. You can actually press the number 1 because it says actions number 1. So you can press menu 1 and then press 1 again for define. Okay, so you press menu 1. That's a shortcut to get there. I want you to get used to the word define or this function. This will help you do a lot of things like substituting, solving intersects and all that, finding maximum minimums. This is going to be one of the easier ways to do. Okay, so here, define. Now, just to get in the mode of things, of function notation, we use letter F instead of Y now, or V. Comma, open brackets just next to the 0 over here. X, okay, X is your T, right? So that instead of the T, we're using X now. So the function is equal to, we said 500 minus 2.5 times not T, but X. Why do I want you to write X and not T? Is because we're going to graph it. And if you graph it, the calculator only graphs X and Y's. It doesn't graph T's. Okay, so in this case, that's why I'm using X's at the moment. Yeah? Press enter. Now, why did I want you to learn to use this define? Okay, the reason why is that you're going to start practice, especially when you get to quadratics. You know, there's questions where they say, if it was 3 minutes, how much is left in the volume? What you would have done is you would have subbed 3 into the equation. So you would have put 3 here, negative 2.5 times 3, and then 500 take away that on your calculator, right? You don't have to do it now. You can actually do it just by typing F bracket. Now instead of, if you wanted to sub 3 in, well then you replace this X with a 3, and it does it for you. Oh, sorry, let me change that. That's 492.5, which is the same thing if you had typed 500 minus 2.5 times 3. See, that takes a while to do. It's the same answer. But by defining it, you can do a lot of things now. You can solve for the volume. So you know when they say, what if the volume you want in that drip, what if you want 400 mils? How long before it becomes 400 mils? How you would have done it is you would have replaced the volume. You would have said, when will it equal to 400? And then solve for X, right? We can do it all in this one step. You can actually go solve, so you go menu. So another one I'm going to teach you, 2 skills here today. Menu, algebra, so menu 3, that's a shortcut, menu 3, and then 1 for solve. So menu 3, 1. If you press menu 3, 1, so what are you solving? You can tell the calculator, you want f of x, that's your y value. You want the volume to be 400 mils, as a hypothetical question. 400 mils is equal to f of x. So you're saying, I want the y value to equal to 400 mils, and then what do you want to solve for? You're trying to solve for time. You want to say, how long does it take? Right? Instead of doing it algebraically, you can do it on a CAS just like this. So how do you tell it to solve for x? Comma, just on the bottom next to the O, there's a comma here, and then type x. So you're telling the calculator, what if the volume is 400? I want you to solve for x for me. Okay, if I press enter now, it tells me that after 40 minutes, that drip, if you kept minusing 2.5 every minute, by 40 minutes, it'll reach 400 mils. Can you see the benefit of being able to just define, and imagine doing that for quadratics. So quadratics with double brackets, solving for the x-intercepts, solving for the y-intercept. You can do it all in 3 steps. Okay? So that's going to be very useful. I only taught you 2 key things, define and function. Define is menu 1.1. Solve is the second thing I taught you. That's menu 3.1. Get used to those shortcuts and you get faster with your CAS. Okay? All right, so let's go back to our question over here. So this is our model. Let's see part B. So part B says, state the possible values of T and V. A lot of students stop here and they don't know what this means. I'm going to show you visually what it looks like. So remember how you defined it? You typed f of x. Now let's graph it. Let's graph it to visualize what it looks like. So I want you to now press Control Control, and then doc. Okay, so document, and this little shortcut should come up. We're going to graph. So we're going to add graphs. Let's go to add graphs. So here, instead of retyping the equation again, especially when we get to quadratics, the equations could be big. You don't want to type it over and over and over. Because you defined it once in the first step, you can now just type in f bracket x. That is the same thing as saying 500 minus 2.5x. Instead of typing that, you can just type f of x. So if I press enter now, and I know you can't see it because it's 500 mils, so it's really up high. So how do you visualize it? Right now it's only between 6 to -6, -10 to 10. You can actually go to menu, Windows. Okay, now you can either adjust it manually, Windows settings. You manually adjust the domain and the range, or one of the cheat ways that I normally teach my 12, sometimes it works, sometimes it doesn't. You go to zoom fit, and the calculator tries to fit the graph as best as it can for you. So if I go to zoom fit, there we go. That's my graph there, but the problem is I can't actually see the x-axis, but I see that at 530 I can see the graph pretty clearly. So maybe I'll go to the manual setting now and I'll change it. So I go menu again, 4.1, so window settings. And what am I going to change? The minimum. So that Y minimum, instead of it being 400, let's go all the way down to -10 as an example. Let's see if I can see it now. Is it Y values? Oh, wait, that doesn't look right. Oh, sorry, it was the X. X I need to fix. So I need to fix, change to, maybe try change maximum X to be, what should it be? Blah, blah, blah. Let's try 300 for now. And minimum X, let's try -100. Let's see what that looks like. There we go, that looks much better. You see what I did? So I changed the X to be a maximum of 300. And I can see the x-intercept now. And if you kept it as 530, you can see the y-intercepts up there. This is your graph. You can keep manually changing if you want. You can use the mouse section. See how I'm sort of just moving it so it adjusts better. Now, how did I do that on the screen? See how I can move it left and right? If you want to do that, see that little hand icon? This is how you're going to do it. See that pad where it has a little hand? If you press on that pad anywhere on this screen, the hand will come up and then you can move it left and right to adjust the window. Okay? All right, let's screenshot this. I'm going to screenshot this and then let's talk. Here we go. So part B. In your graph, part B, this is what you should have so far. Part B. I'm going to move this closer there. Okay, let's analyze. So they said find the appropriate x and y, x, not x, t and v values. If you look at this graph here, what can't you have? Logically, what values can this graph not have? Because you can't sketch everything. It doesn't make sense in this situation. What's negative? Very good. You can't have negative volume, so it doesn't make sense that if you started at 500 mils, the maximum was 500 mils, and you slowly lose 2.5 mils, eventually you empty the bag, it's at 0. How is it possible to have negative volume? The bag doesn't have negative volume. So that means this part of the graph cannot be accepted. You can't have this section of the graph. What else can't you have? That's true. Volume of maximum is 500 mils. This thing doesn't hold anymore. But also, time can't be negative. How can you have -2 minutes? Doesn't make sense. So this part of the graph shouldn't exist either. So if this part of the graph shouldn't exist, then now what is your range of values that your t and v's can be? Well, if we look at it, this is your v-axis. V can only be at the maximum, which we knew was 500, all the way down to 0. So if you were to write it, V can only be bigger than 0, but less than 500. You see what I'm doing there? I'm saying V, the volume can be equal to 0, but it has to be greater. But it can only equal to 500, and it has to be less. That's what they mean by stating the appropriate values for V. What about time? Well, time, clearly you can't have negative time, but you can start off with 0. So at the beginning it had 500 mils. So you'd say, yep, T is definitely bigger than or equal to 0. But at some point, after a certain time, it is going to empty the bag. So the question is, when will the volume of the bag be 0? There's no more liquid or the saline solution in the bag. How long? Now you can use your CAS to solve that. You're asking, when will the volume equal to 0? Solve for T. So using the skills I just taught you, have a go. See if you can figure out what that is. Or you can do it by hand as well. You can solve for T. And let's see, I'm going to use my calculator. To go back, you do Control and tap the arrow button to the left. So do Control, whoops, not Control, not Tab. Control, arrow, and I'm back to the screen. Let's do it. Solve. Menu 3-1. Solve. What do I want the volume to be? I want the volume f of x to equal to 0. I need the volume of the saline solution to be 0. Tell it to solve for x, because x is my time. Tells me it's 200. So that tells me, right now I know, this must be 200 minutes. That's how long this bag is going to survive for if it continuously loses 2.5 mils every single minute. After 200 mils, this bag will be empty. Okay, so that means my time can only be between 0 to 200 minutes. Okay, and you could have done that by hand as well. So you could have solved for this one by hand. You could get 0 equals 500 minus 2.5t, and you could do what you've done back in year 9 and 10, minus the 500, divide both sides by negative 2.5, and you would have got the same answer. Okay? All right. And obviously the sketching part, well, we've already done most of it. If you've done the analysis correct, the graph should have been V, T. Make sure when you're drawing the graphs, label it correctly. V and T. Axis intercept, which we knew was 500. Write it in coordinates, so 0 to 500. And then over here, that should be 200, 0. Draw the line. Use a ruler if it's a straight line. If you don't use a ruler, I will penalize you. At year 12 level, if it looks wonky, you're saying it's a curve and not a straight line, so you must use a ruler. Notice I use closed circles to mean that you can have 500s and you can have 200 as T. That is what they mean when you're sketching appropriately. Okay, so this is a very typical linear equations model that you would do for a SAC or something like that, year 11 methods, fluency skill. This is not a hard question, this is a typical question. Quadratics will be similar too. So you will go through the same kind of steps, model, talk about domain and range, and then sketch. That's what you do in chapter 3, and that's what we do in chapter 2 as well. Okay? So far, so good? All right? I'm gonna leave that there. I'm gonna give you a bit of space. So that's currently 12:44. I know there's another example on the back, but I want you to have a go with the CAS. Okay, you should do it much faster if you do it with the CAS. The hardest part is modeling. So model it. I'll write the solutions later on. But have a model, have a bit of your time, look at 2G, and we'll come back at 1 o'clock. So I'll give you 15 minutes of your time, have a look at 2G, and then we're going to spend that last half hour on 2H. And I'll show you a bit more CAS work for 2H. Okay, we'll start the video.